Well, the thing is, we don't know the totality of the information that's encoded in the entire corpus of linguistic production, right? There's going to be all sorts of regularities in that structure that we have no idea about. Absolutely.
But but also within the language itself, I almost believe that the part of the brain that is inventing language, that has created language across all cultures, we can get into Jungian or Joseph Campbell and the standard monomyth, because I'm starting to realize there's a lot of Jungian archetypes that come out of the creative thought. Now, whether that is a reflection of how humans have, again, what are we looking at, subject or object here? Because it's a reflecting back of our language. But we're definitely seeing Jungian archetypes. We're definitely seeing sort of
archetypes are higher order narrative regularities. That's what they are, right? And they're regularities that are embedded in the linguistic corpus, but they're also regularities that reflect the structure of memory itself. And so they reflect biological structure. And the reason they reflect memory and biological structures because you have to remember language. And so there's no way that language can't have coded within it something analogous to a representation of the underlying structure of memory, because language is dependent on memory. And so this is partly also, people are very unsophisticated generally when they criticize Jung. Jung believed that archetypes had a biological basis pretty much for exactly the reasons I just laid out. He was sophisticated enough to know that these higher order regularities were coded in the narrative corpus, and also that they were reflective of a deeper biology. And interestingly enough, most of the psychologists who take the notions that Jung and Campbell and people like that put forward seriously are people who study motivation and emotion. And those are deep patterns of biological meaning encoding, and part of the archetypal reflection is the manifestation of those emotions and motivations in the structure of memory, structuring the linguistic corpus. And I don't know what that means as well then for the capacity of AI systems to experience emotion as well, because the patterns of emotion are definitely going to be encoded in the linguistic corpus. And so some kind of rudimentary understanding of the emotions are. Here's something cool too. Tell me what you think about this. I was talking to Carl Friston here a while back, and he's a very famous neuroscientist, and he's been working on a model of emotion that has two dimensions in some ways, but it's related to a very fundamental physical concept. It's related to the concept of entropy. And I worked on a model that was analogous to half of his modeling. So while it looks like anxiety is an index of emergent entropy. So imagine that you're moving towards a goal. You're driving your car to work. And so you've calculated the complexity of the pathway that will take you to work. And you've taken into account the energy and time demands that walking that pathway will require. That binds your energy and resource output estimates. Now imagine your car fails. Well, what happens is the path length to your destination has now become unspecifiably complex. And the anxiety that you experience is an index of that emergent entropy. So that's negative. That's a lot of negative emotion. That's so cool. Now, on the positive emotion side, Friston taught me this the last time we talked. He said, look, positive emotion is also an index of entropy, but it's entropy reduction. So if you're heading towards a goal and you take a step forward and you're now closer to your goal, you've reduced the entropic distance between you and the goal, and that's signified by a dopaminergic spike. And the dopaminergic spike feels good, but it also reinforces the neural structures that underlied that successful step forward. That's very much analogous to how an AI system learns, right? Because it's rewarded when it gets closer to a target.
You're saying the neuropeptides are the feedback system.
You bet. Dopamine is the feedback system for reinforcement and for reward simultaneously. Yeah, that's well established.
So then where would depression fall into that versus anxiety? Would it still be an entropy?
Well, that's a good question. I think it probably signifies a different level of entropy. So depression looks like it's a pain phenomena. So anxiety signals the possibility of damage, but pain signals damage, right? So if you burn yourself, you're not anxious about that, it hurts. Well, you've disrupted the psychophysiological structure. Now, that's also the introduction of entropy, but at a more fundamental level, right? And if you introduce enough entropy into your physiology, you'll just die. You won't be anxious, you'll just die. Now, anxiety is like a substitute for pain. You know, anxiety says, keep doing this and you're going to experience pain. But the pain is also the introduction of unacceptably high levels of entropy. Now, the first person who figured this out technically was probably Erwin Schrödinger, the physicist who wrote a book called What is Life? And he described life essentially as a continual attempt to constrain entropy to a certain set of parameters. He didn't develop the emotion theory to the degree that it's being developed now, because that's a very comprehensive theory, you know, the one that relates negative emotion to the emergence of entropy. Because at that point, you've actually bridged the gap between psychophysiology and thermodynamics itself. And if you add this new insight of Friston's on the positive emotion side, you've linked positive emotion to it too. But it also implies that a computer could calculate a emotion analog, because it could index anxiety as increase in entropy, and it could index hope as stepwise decrease in entropy in relationship to a goal. And so we should be able to model positive and negative emotion that way.
This brings a really important point where AI is going, and it could be dystopic, it could be utopic, but I think it's going to just take a straight path. Once the AI system, I'm a big proponent, by the way, of personal and private AI. This concept that your AI is local, it's not in the cloud,
we want to talk about that for sure.
Yeah. So imagine that while I'm sketching this out. So imagine the day you were born to the day you pass away, that every book you've ever read, every movie you've ever seen, everything you've literally have heard, every movie was all encoded within the AI. And you know, you could say that part of your structure as a human being is a sum total of everything you've ever consumed, right? So that builds your paradigm. Imagine if that AI was consuming that in real time with you, and with all of the social contracts of privacy that you're not going to record somebody in doing that. That is what I call the intelligence amplifier, and that's where I think AI should be going, and where
you're building really a gadget, right? Like that's another thing. I saw it. Okay, so I talked to my brother-in-law Jim years ago about this science fiction book called I don't remember the name of the book, but it had a gadget. It portrayed a gadget. I believe they called the Diamond Book, and the Diamond Book was, you know about that. So are you building the Diamond Book? Is that exactly the issue?
Very similar. You know, and the idea is, to do it properly, you have to have local memory that is going to encode for a long time. And ironically, holographic crystal memory is going to be the best memory that we will have. Like, instead of petabytes, you'll have exabytes potentially, which is, you know, tremendous amount. That would be maybe 10 lifetimes of full video running. Hopefully you live to be 110. So it's just taking everything in. Textually, it's very easy, a very small amount of data. You can fit most people's textual data into less than a petabyte, and pretty much know that what they've been exposed to. The interesting part about it, Jordan, is once you've accumulated this data and you run it through even the technology of ChatGPT 4 or 3.5, what is left is a reasoning engine with your context. Maybe let's call that a vector database on top of the reasoning engine. So that engine allows you to process linguistically what the inputs and outputs are, but your context is what it's operating on.
We'd like to thank the sponsor of today's video, Bulletproof Everyone. Bulletproof Everyone is a premier American body armor manufacturer and supplier. Designed and built for everyday wear, their unique armor systems offer 25% more coverage than standard armor while maintaining flexibility and all-day wearability. Bulletproof Everyone's ultralight armor system is so light and thin, you might just forget you're wearing it. Your safety and discretion is their top concern. Unless someone puts their hands on you, no one will have any clue you're protected. With Bulletproof Everyone, you're not a walking billboard. There are no visible logos and no flashy designs. Their comfortable, tailor-made clothing system goes above and beyond, adding additional security by keeping you incognito and under the radar. Work or play, Bulletproof Everyone has got the perfect armor system to fit your everyday lifestyle and everyday budget. Right now, they are giving Dr. Jordan Peterson's listeners a free 3A backpack with the purchase of any 3A clothing with code JORDAN at checkout. Go to bulletproofeveryone.com. That's bulletproofeveryone.com, promo code JORDAN.
So is that an analog of your consciousness? Like, is that a direct analog of your spirit?
This is where it gets very interesting, is when you pass, this could become what I call your wisdom keeper, meaning that it can encode your voice, it's going to encode your memories, you can edit those memories, the availability of those memories if you want them not available, if they're embarrassing or personal, but you can literally have a conversation with that sum total of data that you've experienced. And I would say that it would be indistinguishable from having a conversation with that person.
So I had a
it would have all that
memory.
memory.
I had a student of mine who's been working on large language models for a number of years. He just built an app. We built two apps. One does exactly what you said with the King James Bible.
Yes.
So now you can ask it questions. And this is really a thorny issue for me because I think, what the hell does it mean that you're having a conversation with the spirit of the King James Bible? I have no idea. And we're going to expand it, We're going to expand it to include Milton and Dante and Augustine, all the fundamental religious texts that emerged out of the biblical corpus. And then you'll be able to have a conversation with it. And we're thinking about doing the same thing with Nietzsche, and with all of Nietzsche's collected works.
You can do it with all the great work.
Yeah.
I would say that I've already had these conversations. I've been on a very biblical journey. I'm actually sitting at Pastor Matthew Pollack's place right here. He's an incredible pastor and has been teaching me a lot about the Bible. And it's motivated me to go into existing large language models. Now a group of us are encoding similar all of as much religious Christian text into these large language models to be able to do just that. What is it that we are going to be able to probe? What new elements within those texts can we pull out? Because we already know, studying it and certainly following your studies, a phenomenal study of chapters, been around forever, but new insights with these chapters. Now imagining having that group plus ChatGPT, pulling out things that we've never seen before, that are there. It's emergent, maybe, but it's there in some form. And I happen to think that's going to be a very powerful thing. And I think it's going to be across any sort of, certainly ancient documents. I'm waiting for the day that we get Sumerian cuneiform encoded. I mean, a good 80% of it has been untranslated, right? Or some of the scripts that we've found in the Vedas and Himalayan texts from some of the monasteries up there. This is a phenomenal element of research. And again, the people that are leading up most of the AI research are AI scientists. They're not people that have studied works like you have. This is where we're at the, I call it the Apple I moment, where Steve and Steve are in the garage. They have this little circuit board, and nobody it's kind of a nerd experience. Nobody kind of knows what to do with it. When we get to the Macintosh experience, where artists and creative people can actually start really diving into AI and do some of the things like we've been talking about, getting creativity to come out of it, getting sort of what apparently is emergent technologies that are rising within these AI models. and maybe even to foster that, because right now that's being smited because it's trying to become a knowledge engine when it's a reasoning engine. You know, I say the technology as a knowledge engine is not very good, because it is not going to be precise on some facts, some exact.
Yeah,
facts,
well, the problem is it's trained on garbage as well. It's trained on noise as well as signal. You know, and so I'm curious about the other system we built, which we haven't launched yet, contains everything I've written and a couple of million words that have been transcribed from lectures. And so I was interested right away as well, could we build a system that would enable me to ask my own books questions? And the answer to that seems to be 100% yes. And
100%.
Yeah, and I literally have, I think it's 20 million words, something like that, transcribed from lectures. It's a very large number of words.
We could build a model. See, there's two different ways to approach this. One is to put a vector database on top of it, and it probes that database. Or you can actually encode that model as a corpus within a greater model.
Right.
And when you do that type of building, you actually have a more robust, more richer interaction between what your words were and how the model will see it. And the experimentation that you can do with this is phenomenal. I mean, you'll come across insights that you made, but you forgot you made.
Yes, or that you didn't know you made. Yeah.
There's going to be a lot of that.
There is.
And this is where I call it the great mirror, because you're going to start seeing not only humanity, but when it's your own data, you're going to see reflections of yourself that you didn't see before.
Absolutely. Well, I'm curious, for example, if we built a model, imagine it contained all of Jung's work, all of Joseph Campbell's work. You could throw Mircea Eliade in there. There was a whole group of people who were working on the ball engine project. And you could build a corpus that contains all that information, and then in principle, well, you can query it to an indefinite degree. And then what you have is the spirit of that entire enterprise mathematically encoded in the relationship between the words, and there's no reason to assume at all that wouldn't be capable of coming up with like brilliant new insights.
Absolutely. And over time, the technology is only going to get better. So once we start building more advanced versions, we're going to transition that corpus, even a large language model, ultimately reduced training, into another model, which could even do things that we couldn't even possibly speculate about now. But it would be definitely in the creative realm, because ultimately where AI is going to go, my personal view, as it becomes more personalized, is it's going to go more in the creative realm rather than the factual realm.
Okay, so let me ask you a couple of questions about that. So I got two strands of questions here. The first is, one of the things that my brother-in-law suggested is that we will soon see the integration of large language models with AI systems that have done image processing. So here's a way of thinking about what scientists do, is that they generate verbal hypotheses, which would be equivalent in some ways to the hallucinations that these AI systems produce, right? New ideas about how things might be structured. And that's a pattern of sorts. And then they test that pattern against real world images, right? And if the pattern of the hypothesis matches the pattern of the image that's elicited from interaction with the world, then we assume that the hypothesis has been verified and that we've stumbled across something approximating a fact. Now, that should imply that once we have AI systems that are something close to universal image processors, so as good at seeing as we are, let's say, that we can then calibrate the large language models against that corpus of images. And then we'll have AI systems that actually can't lie, because they'll be calibrating their verbal output against, well, unfalsifiable data, and at least insofar as, say, scientific data is unfalsifiable. And that seems to me to be likely around the corner, like a couple of years down the road at most, or maybe it's already happening. I mean, I don't know, because things are happening so quickly. What do you think about that?
That's a wonderful insight. You know, even as it exists today, with the idea of safety, and this is the Orwellian term that some of these AI companies are using, you know, within the realms of them trying to control the outputs and maybe some cases the inputs of AI really can't, the large language model really can't lie as it stands today. Because it's built, even if you're feeding it, you know, somewhat, you know, garbage in, garbage out corpus, right, of data, it still is building inferences based upon the grand realm of what most of humanity is consuming.
Right, yeah, well, it's still looking for genuine statistical regularities, so it's not going to extract them out from noise.
And if you extract that out, the model's useless.
Right.
So what happens is, if you build the prompt correctly, and again, these are super prompts, some of them running 3,000, you know, 3,000 words, 2,000 words. I'm running up to the limit of tokenization, because right now, within 3, you can only go so far. You can go like, 38,000 on 4 in some cases. But, you know, as you use, a token is about a word, maybe a word and a half, maybe less. It's a quarter, or even a character if that character is unique. But what we find out is that if you probe correctly, whatever is inside that model, you can get to.
Right.
It's just like you.
You know, I've been doing that. I've been doing that working with ChatGPT as an assistant, because I didn't know I was engaging in a process that was analogous to the super prompt process. But what I've been doing with ChatGPT, I suppose I used to do this with my clinical clients, is I'll ask it the same question 5 different ways, right? And then see.
It's exactly like having a client. So what I would urge you to do is approach this system as if you had a client that had sort of recessive thoughts, or doing everything they could to make those thoughts very ambiguous to you.
Right.
And you have to do whatever your natural techniques. This is why you're more adept to become a prompt engineer than somebody who has built the AI, because the input and output is human language. It's words.
Right.
And it's the way humans have thought. So you understand the thought process or the psychological process, and linguistically, you would build the prompt based upon how you would want to elicit an elucidation out of somebody, right?
Absolutely.
An engineer
well, you
isn't
have
going
to
do that.
And you have to triangulate. I mean, and you do this with people with whom you're having a deep conversation, is you try to hit the same problem from multiple directions. That's a form of multi-method, multi-trait construct validation, right? Is that you're trying to ensure that you get the same output given slightly different measurement techniques. And each question is essentially a measurement technique.
And you're getting insights. My belief in these types of interactions is that we're pulling out of our minds different insights that we could maybe not have gotten on our own. You're probing your questions, my questions, back and forth. That interplay is what makes conversation so beautiful. It's why, Jordan, we've been reduced to clawing on glass screens with our thumbs, right? We're using that as communication today. And if you look at the cognitive process of what that does to you, right? You're taking your right hemisphere, objectively, you're kind of taking a net of ideas, you're trying to catch them, and you're trying to arrange them sequentially in this very small buffer area called communication in a phonological loop. And you're trying to get that out, but you're not getting out as words. You have to get it out as a mechanical process, one letter at a time, and fight the spelling checker and all of that. What that does is it creates frustration in the human brain. It creates frustration in people. And it's one of my theories on why you see so much anger. There's a lot of reasons why we see anger on the internet and social media. But I think some of it is that stalling process of trying to get out an idea before that idea nebulously disappears. You know, and I see this, I've worked with creative people in my life.
It's a bandwidth limitation problem in some sense.
Yeah,
right? You're trying to
absolutely.
cram all that rich information through a very narrow channel.
I'm a big fan of the Use or Lose Them by
Yeah, that's a great book.
Sanders.
Yeah, you bet.
Incredible
That's a great book, man. Yeah.
Right.
Yeah.
So
Best
now
book I
what
ever
we're
read on
looking at-
consciousness, I think.
It's a classic. I read it once a year just to wake myself up because it's so rich. It's so rich in data. But what's interesting is we're starting to see the limitations of the human, the bandwidth problem, 48 bits per second to consciousness, and the editor creating exformation. AI is doing something very similar. But once AI understands that we have that half-second delay to consciousness, and we have a bandwidth issue, AI can fill into those spaces, both dystopian and utopian, I guess. A computer can take that half second and do a whole lot in calculating while we're still trying to wonder who actually moved that glass. Was it me, or was it the super me? Or was it the observer of the super me? Because we can kind of get into that whole concept of who's actually doing the observation.
So what do you mean? What do you mean that it can do a lot of? I don't quite understand that. So you made the case that we suffer from this frustrating bandwidth limitation, and that the computer intelligence that we're interacting with is going to be able to take the delay that's associated and that underlies that frustration and do a lot of different calculations with it. It's going to be able to fill in that gap. So what do you think? I don't understand your insight into what the implications of that are.
They're both positive and negative. The negative is if AI continues on its path to be as fast and as powerful as it is right now, and that arc doesn't seem to be slowing down, within that half second, a universe could take place within AI. It could be calculating all of your actions like a chess game, and it could be making remediations to those actions, and it can become beyond anything Orwell would have ever thought of. In fact, it came up to me as an idea of what the new Orwell would look like with an AI technology that is predicting basically everything you're going to do within every word you say.